Morning. I wanted to take a little bit of a time to go over what we talked about yesterday in class with density. It was a little bit ratchet because I wasn't really prepared to do it. I was just going to sort of do an overview, and then I ended up getting into a lot of detail. So I wanted to slow down and write a little more clearly on the board and allow you to stop and watch the video and so forth. So this this lesson's about density. And if you watch the video that's in the announcements, which I recommend that you do, the idea of density is the idea of how much matter is smashed together into a certain amount of space. So if there's a lot of matter that's smashed together in a small amount of space, we say that the density of that object is high. And if there's very little matter, no molecules or very few atoms, and they're spread out over a large amount of space, think of a gas, then we would say that that object has low density. So it has to do with the closeness or the compactness of matter inside of an object. So, for example, in this iron probably weighs, I'm going to give it to you in pounds just for a reference, weighs about 6 pounds, which is about 3 kilograms, because remember, a kilogram is about 2.2 pounds. So it's very, very heavy. It's a lot of matter smashed into a relatively small space if you compare it, for example, with this graduated cylinder. The graduated cylinder has very little matter. The only inside is empty. So it has very little matter, and it's in a very large space. So just feeling the two of these, this one is much heavier. It's a lot more matter compacted into a small amount of space. This one feels lighter, even though it's very large. It doesn't have very much mass. There's not very much matter in it. So that's the property we're talking about. How much matter, how many atoms are smashed into how much space, and that's the description of density. Something that mass doesn't quite do, because if you say something has a lot of mass, then the Earth has a lot of mass, but it's also very large. It's proportional. Or you could say a black hole has a lot of mass, but it's actually very, very small. It's very compact. So it's a function of how much matter, again, is smashed into how much space that can kind of give you an idea of that's what density is. Okay, so in saying that, and it's going to help you, I think, a little bit when you look at the math, because in this case, math does help you. It'll help you visualize and understand with numbers the concept that we're talking about. Okay, so we have to remember that density is a measure of how much mass or how much matter, the mass of the matter in a certain amount of space, which is volume. So that's what density is. How much mass or how much matter is in that volume. The way we know how much matter there is that we take the mass of it on a scale. Okay, so that's our equation that we're going to be working with. It's a fairly easy one. In order to calculate density, determine density, we have to know the mass of the object and we have to know the volume of the object. All right, so mass is fairly simple. The units for mass that we're going to be using, mass is fairly simple. Since it's the metric system, all of your mass measurements are going to be in grams, kilograms, milligrams, so anything with that gram at the end. Okay, centigrams, we don't use those as much, but usually there's grams, kilograms, or centigrams. So whenever you see anything with the gram in it, you know we're talking about the mass, how much matter is there. Okay, and you can measure this on a scale. This is easy. The next thing that you have to know to calculate density is the volume. How much space is that object taking up? So volume of an object can be measured or determined a couple of different ways, and so it has two different units typically that you can use to express volume. So volume can be liquid. So if we're measuring a liquid, okay, for example, some water, okay, it's easy to measure the mass of the water. We just put it on the scale and we subtract the beaker and we know the mass. That's easy. That doesn't change. It's going to be in grams or kilograms or whatever. But the volume of a liquid has to be determined with a graduated cylinder, and we measure that in liters or milliliters typically. Okay. So if we're taking the volume of a liquid, if we're trying to get the density of a liquid, then we use milliliters liters, kiloliters, but typically it's milliliters or liters is what you see. We'll convert it to liters or convert it to milliliters. This is a liter. Remember, a milliliter is about the size of a tear. This is a whole liter, and it's divided up. Okay, so that's how we would determine the volume or how much space a liquid takes up. We use a graduated cylinder or beaker, and we just read. It's easy. Okay, but not everything's a liquid. We might want to determine the density of a solid. So there are two types of solids. We categorize our solids. Okay, so if you want to determine the volume of a solid, then a regular solid, what we call a regular solid. Regular solid means that there is a formula that can describe it. It's a shape that can be described. So a sphere, for example, this is a regular solid. There's actually a formula that we can use to determine the volume of a sphere. Actually, this is a regular solid. I don't know what the formula is for determining this, but this is a 1, 2, 3, 4, 5, 6, a hexahedron or something like that. So is this. These are all regular solids, regular shapes. Okay. A rectangle. Okay, this box. This was a regular shape. Okay, it has right angles on it. And there is a formula, length times width times height, that you could use to determine the volume, how much space this box takes up. Now, you don't even know if it's empty or not, so you don't know the mass of it, but we determine the mass, and then to get the volume, how much space is this thing taking up, we would use a formula. All right. Also, cone. A cone is another regular shape. Think of a cone. Okay, so your solids, if it's a regular solid, and some examples are a cone, I'm going to call it a cube. That's not what it's called. You'll have to ask. I don't know. But it's this thing, like a regular square shape rectangle, like that. A sphere, which is your ball. Just put ball next to it. I'm going to put box, like something that's like a box next to the cube. You understand what a cone is? Okay, if you have something that's a regular shape like that, it has a formula. So for example, if you're measuring a cube or a box, you take the length times the width times the height. Okay. If it's a sphere, I actually wrote this down. It is, the formula for sphere is, for the volume, is 4/3, and I don't expect you to memorize this. You know, if you use these a lot, you can, but if not, you can always just look them up. Is 4/3 pi r cubed, and for a cone, it's something else. Your lesson tells you what it is, but there's a formula for each of these. So if you're trying to determine the volume, again, this is under volume, if you're trying to determine the volume of a regular solid, you're going to use a formula. All you have to do is be able to identify what is the regular shape that you have. Again, it's either going to be a cone, a sphere, or a cube, some sort of a box. You just look up the formula, okay? And you have to just, that's it. It's not going to get any more complicated than this. All right, but remember, you're going to use a formula. Now, length and width and height or radius, those are all distances, okay? So you're going to be measuring the distance around this sphere, okay? It's asking you for the radius, or you're going to have to measure this. It's a distance. So you're going to be using length, meters, millimeters, centimeters. So anything that's a regular solid has a formula. You're going to be using distances, length, width, height. Those are all distances. And if you have a small cube, like the box that I was showing you, okay, like our little box here, you're going to be measuring probably in centimeters. Something small like this is in centimeters. If you're measuring something large like a desk, you might use meters. Have to be even bigger than that, but okay. So you take the appropriate distance unit. So for a regular solid, okay, so this is the key word here is solid, you're going to use distance measurements. Okay, which means meters, millimeters, centimeters, and maybe if you have a really large object, maybe a kilometer, okay, kilometers. But because you're always multiplying three of them, three sides, there's always going to be three distances in each formula. There will always be three. that your distances are always going to be cubed. So if you are measuring the volume of a regular solid, the units are going to be meters cubed, some sort of a distance cubed, like millimeters cubed, centimeters cubed, kilometers cubed. You're always going to see that 3 there because when you perform the function, the formula, you're going to end up multiplying 3 distances together, okay? And whenever you cube something or you square something, is you're multiplying the same thing twice by itself, twice or 3 times. You're going to be measuring a distance 3 times by itself. So length, width, height. 3 centimeters times 3 centimeters times 3 centimeters. So you're going to have centimeters times centimeters times centimeters cubed, okay? Or meters times meters times meters cubed. It works that way for all of the regular solids. You're always going to end up with that cubed distance unit, okay? All right. The last thing that you can have for volume, you either have a liquid, easy peasy, milliliters or liters, regular solid, you use the formula, or you're going to have an irregular solid, which is like this. We talked about this yesterday. And this is it's a solid, so you can't pour it in anything unless you melted it down. But it's not regular. There's no formula that you can just look up on Google and say, what's the formula for an iron, or something like that, because they're all different. It's not a standard form. It's not. So how do we determine the volume of something that's irregular, but it's a solid? Okay, so that's the third case. We're still under volume here. So we have a regular solid, liquids, regular solid, and then an irregular solid. How do we determine the volume of an irregular solid? I'll put volume over here so we know this is what we're talking about. These are all the volume. So you get volume. Mass is easy. Okay, you just put it on a scale. An irregular solid is by what we call water displacement. We talked about this yesterday, but water displacement, that is the third way to determine volume. If you have an irregularly shaped object, you actually have to submerge it into a known amount of water. So let's just pretend this would fit in here. So if I knew that I had, 90 milliliters of water, something like that, or centiliters of water, and I submerge this down inside of the graduated cylinder, then water and my iron can't take up the same space at the same time. Only one thing can occupy a space at a time. So once the iron goes in, the water has to move, or the air has to move. If I submerge this into the air, even the air is actually billows out. We just can't see it. So we need something that we can see and we can measure. I can't measure the amount of air that's going to be floughing out if I submerge my iron, but I can with the water. So I would fill this up with some water, my cylinder. I would submerge my irregularly shaped object, and however much space my iron is taking up, the water has to move out of the way. Well, where's the water going to go? The water is going to move up as my object is submerged down, and you can measure how much the water moves up, and that is the volume or the space that my object is taking up inside of the cylinder. So that's how that works. So it ends up being easy because you're dropping, you don't have to measure anything. You're not length times width times height. You're just dropping the object in, the weird shaped object in. My keys would work. Okay, what is the volume of my keys? I fill this graduated cylinder up a certain amount, drop my keys in. However much the water moves up, that's the volume of my keys. And they are definitely irregularly shaped. Okay, there's no formula way to figure that out. So I can get the mass of my keys, put it on a scale. Volume of my keys, drop it in the water moves up, out of the way, the amount that my keys occupy. So an irregular solid is water displacement. And that means you're dropping it in the water and you're seeing how much water it displaces. And you can stop the video there if you want to and kind of jot that down. Okay, so saying that, now we have our measurements. We have our mass, and now we know how to get the volume of whatever the thing is that we're measuring, either a liquid, regular solid, or an irregular solid. All right, so I'm going to erase this now, and I'm going to give you an example. You know what I'm going to do? I'm going to stop the video here, so at least you have that, and then I'm going to do a second video where we actually do an example with our golf balls, which are regularly shaped objects, And so if you don't need anything more and you understand where to go from here, you can stop the video and you're fine. If you want to continue on to the next video where I'm actually going to be talking about and giving you examples of how to determine the volume of two objects that are, excuse me, not the volume, the density of two almost identical balls. They're different masses, but the same volume. Okay, and we're going to explore density a little bit more. Okay, hope that was helpful.